Hello everyone, welcome to Structural Insights. My name is Shilpa Dikshit. I welcome you all to this lecture. In this video, we will be discussing IS 2911 Part 1 Section 2 2010. This IS code is about design and construction of pile foundations. The Part 1 is for concrete piles and the Section 2 of this Part 1 is for poured cast and situ piles. This will be the second revision. Okay. In this video, the main objective of going through is solving problems on the Annexure B, evaluation of pile vertical load carrying capacity in the stratified soils. So for going ahead with this calculation, we must have a geotechnical report of the site, or if it is not available beforehand, we can use any other site which is adjacent to the building, and we can evaluate the soil load carrying capacity from that report, and we'll have some idea of the site of our interest. So let's see our code first. Yeah, this is our IS 2911 Part 1 Section 2. This code, we have already seen the main body of the code, right? Then we have seen Part 1, what is the Annexure B is all about. This is Annexure B. In this we have load carrying capacity of the piles, static analysis. In the granular soils means sandy soils. So we have this formula for sandy soils, and for piles in cohesive or clay soils we have this formula, right? So what does this formula imply? So this formula has two parts, right? First component and the second component. The first component here is the end bearing component. The second one is the skin friction component. This is valid for granular as well as the cohesive soils. In cohesive soils also you will see we have two components, right? First one is for the end bearing and second one is for the skin friction. So let's just have a brief go through about what are the components. So here we see QA is equal to AP. QA is ultimate load capacity. AP is the area of the cross-section area of the pile. 1/2. D is the diameter of the pile. Gamma is the effective unit weight of the soil at the given depth. N gamma is the soil bearing capacity factor, which actually you see here, bearing capacity factors depends on the angle of internal friction phi. So this N gamma we have to refer IS 6403, right? We will see from that code how N gamma is evaluated, or it is interpolated based on the phi values. Phi means angle of internal friction. So we have PD. PD is what? Effective overburden pressure for the ith layer, and here also effective overburden pressure at the pile tip. So PD, there is a trick in calculation of PD. You see this note 5. In note 5, we have, in working out the pile capacity by the static formula, the maximum effective overburden pressure at the pile tip should correspond to the critical depth, which may be taken as 15 times the diameter of the pile shaft for phi less than equal to 30 degree and increasing to 20 times for phi greater than equal to 40 degree. So what does it actually indicate? So to understand this, let's just have some so let's just see this. So we have this soil. Okay, let me just make this sheet a little bigger. Okay, yeah. So we have this soil top. Okay, and then we have pile. Okay, so pile can go up to say 25 meters, right? It can go up to 25 meters. So you will say when evaluating PD, which is equal to gamma dash into depth of embedment. Okay, we'll say DE. So this at this depth, say 25 meters, what will be your DE, depth of embedment? This is what the point number 5 is explaining. So point number 5 is telling us that if your phi value, it is less than 30 degrees or equal to, you take your depth of embedment as 15 times diameter of the pile. If phi is greater than or equal to 40 degrees, you take depth of embedment as 20 That's it. You cannot go beyond 20D, and for 30 degree you have to take 15D. Okay, so this we have to keep in mind. Even if your depth is more than 20D, you will not go say up to this 20D. Say your diameter of the pile is 0.5. Okay, so 20D will be equal to 10 meters. Okay, so say 10 meters. Up to 10 meters your PD will increase, but after, and here it will be maximum as PD. Sorry, I'll just rub it off. So here it will be PD is equal to 20D. After this, it will be a constant value. For here to here, it will be 20D only into gamma, obviously. So, do you understand? If I plot it, it will be something like this. It is increasing linearly from here to here, then it is constant. Okay, PD is constant in this region. Less than 20D, it is linearly increasing from top. Okay, this has to be kept in mind. So this is all about point number 5. Let's read it again. In working out the pile capacity by static formula, the maximum effective overburden at the pile tip should correspond to the critical depth, which may be taken as 15 times the diameter of the pile shaft for phi less than equal to 30 degree, and increasing 20 times diameter for phi greater than equal to 40 degrees. So this is point number 5. This is valid for this PD as well as this PDI. Okay. Now we'll see these parameters. Ki is the earth. Point number 3 we have to see the earth pressure coefficient depending on the nature of the soil strata, type of the pile, spacing of the pile, its method of construction. For driven piles in loose to sand, phi varying between 30 and 40 degrees. Ki values in the range of 1 to 1.5 may be used. So let's yeah. So it is saying that we have a K value. And to 1.5 based on phi values 30 to 40 degrees. So you will have to actually linearly interpolate. If your phi is this, if k is this, then k is 1 and 1.5 for phi 30 degree, 40 degree. So it will be linearly increasing, right? It's like this. So your phi is this, your slope is this. So for 30 degree it is 1, for 31 degree, 32 degree, 33, 34 up to 40 degree you'll have to get these values from linearly interpolation, right? So this is all about Ki. Then we have PDI, we have already discussed 10 delta. See delta, although this code is saying that angle of wall friction may be taken as equal to the friction angle of the soil around the pile stem. What is the friction angle? Friction angle is nothing but phi. Okay, this friction angle is phi. Okay, and this delta is the wall friction. So generally what code says you can use delta is equal to phi, but I would suggest that as per the literature, if we are boring a soil, the soil gets disturbed, so the friction gets decreased. So the phi value should be decreased by 3 to get delta. Means delta is equal to 5 minus 3 to be used to be on conservative side. Okay, and ASI. So just to explain this, I will keep it here, write it here. Okay, so delta I will recommend to use delta is equal to 5 minus 3. So if your phi is equal to say 35 degrees, we will use delta is equal to 32 degrees. That's what I was saying. And ASI is the area of the shaft for the given layer. So when you have a soil, when you have a pile, right, we have various layers, right? First layer, second layer, third layer, many layers. So let's say first stratum, second stratum, third stratum, fourth stratum, fifth stratum, and many more, right? So suppose we are doing the calculation of skin friction for this third layer. So what is the area of the shaft in this third layer? That is known as ASI. So depending on this, whether this is a clay or this is a sand, based on the soil properties on the lab test, you will identify whether this is a clay or sand, and based on that evaluation, you will do the calculation for the skin friction from Annexure B of the code. So ASI is the surface area of the shaft. This is all about the granular soils. So let's go to the cohesive soils, right? So in cohesive soils, the expressions are a little easier. QU is the ultimate load capacity. First one is the end bearing. So in end bearing, we need the AP, pile tip area, cross section area. And C is the soil, this coefficient, bearing capacity factor may be taken as 9. Okay, NC can be taken as 9. CP is the average cohesion at the pile tip in kilonewton per meter square. So CPA we get from the lab test, average cohesion at the pile tip. We get, then we have skin friction expression. In skin friction, we have summation I is equal to 1 to n alpha I Ci into ASI. What is alpha I? Alpha I is to be interpolated from this graph. We have undrained shear strength from the lab test Cu, kilonewton per meter square, and based on this value we get alpha. So C we already have used here, so you know what is C. So suppose your C is 80 kilonewton per meter square. For based on C you get your alpha. For this particular value 80, we get alpha is equal to say 0.56 or something, 5556 something. Okay, so you must notice that as cohesion is decreasing, the alpha is increasing. Okay, that pattern you have to understand. As the undrained shear strength is decreasing, the adhesion is increasing. So that you have to understand. Okay, Cu is undrained shear strength of the soil. Now we have ASI, which is CI and ASI, which is already we have discussed. CI is nothing but CP at a given layer, particular layer. ASI is the shaft area for the given layer of the soil. So now we will start with the calculations. Now this we have already seen how the calculations are done. This also you can see this NQ value. NQ is utilized here. Okay, this NQ is interpolated from this graph based on the 5 values. Okay, so only this N gamma value, for this N gamma we have to refer IS 6403. Other values are already being taken care of. NQ is here and NC value is 9. So let's go with the Excel table. In Excel, so first of all let's understand what values we will already have and which values we need to evaluate, right? So let's see. So the stratum. In geotechnical report, you will have a stratum. You will have type of the soil already concluded from the lab test. We will have total depth already available with us. We have unit weight of the soil. Okay. So unit weight minus 9.281. That value is also maybe there in the geotechnical report, or if it is not there, you can evaluate doing minus 9.81 or minus 10 as per your convenience. Then we have angle of internal friction. This is also obtained from the lab test. So this is there in the geotechnical report. This is the cohesion. This cohesion is also there in the geotechnical report. So from here to here you will have data from the geotechnical report, and here onwards you will have to evaluate values based on your soil properties or the pile shaft properties. So let's start. So here in this particular case, this soil is just an example. It can be of any site of your interest. In this particular case, the soil has been divided into 5 stratum, 1 to 5, and after looking at the geotechnical report, we have seen that the first layer is extending from 1 to 3 meters. Then in 3 meters we have sand, For next 8 meters we have clay, and another next 4 meters we have clay, and then after 4 meters for up to 7 meters we have sand, and after that 7 meters we have 4 meters of sand again. So this is not the total depth, this is the thickness of these stratums. Now we already have this unit weight. So why these values of sand up to say 3 meter depth we have not done proper calculations? Any guesses? The basic reason for this is that the depth of embedment of the pile, or you can say the pile cutoff length, is minus 3 meters for our case. So we can say that the pile that here we are starting our pile from minus 3 meters. Okay. The ground level is somewhere here, 0.0. So we don't need a soil capacity or the pile capacity in this region. We don't need that. We need it after this. So we have ignored these values up to minus 3 meters. So up to 3 meters, the values have not been considered in the pile load carrying capacity calculations. So we have these unit weight already obtained. This is the gamma dash value. This is the angle of internal friction. See, for clay, we don't have angle of internal friction, right? We don't have any friction, granular friction between the clay particles. We have cohesion in clays, right? So we can see cohesion is given in the clay, and angle of internal friction is given in sand part. This you have to understand, right? Now we have bearing capacity factors. So we have NQ and gamma. NQ and N gamma, they were there in where? Granular soils, right? This is NQ, this is N gamma. And for cohesive soils, we have NC only. So here I have not entered any value for NC. Any guesses why? Because the answer is very simple, that our pile is ending in fifth stratum, which is the sand. So in this expression, NC is used in pile end bearing calculations when it is ending in clay. So here the pile is not ending in clay, it is ending in sand. So we will use this expression for end bearing. So we will ignore this first expression in the end bearing, because this is valid for clay soils. If they are ending, the pile are ending in clay soils. For our case, it is ending in sand. So we will ignore this NC value. It is not at all utilized in this calculation. If it is valid for your case, then you may go ahead with NC value as 9 and do your calculation for end bearing in clay soils. So this alpha, how do you get alpha? Any guesses? So as per the code, alpha is to be interpolated from this CU. So CU is already we have. So based on CU, we have got an alpha. So let's just have a look. So which CU is 12. So what do you get alpha? So CU is 12. So 12 is this. So all the values less than 40, what here it is written as, for CU less than 40, you take alpha is equal to 1. So we have taken alpha as 1. And for C is equal to 60, we have alpha as 0.74. So C as 60. 60 is here. So 0.6, 0.7, something around 0.74 we have taken. So this is how you interpret alpha. K is the coefficient of earth pressure. So this we have already seen. If you come here and see note number 3, what it is saying, if your phi value is 30 degree to 40 degrees, your K will be 1 to 1.5. So you have to see your phi values first. Your phi is 32. 30 for 30, phi and K, right? For 30 it is 1, for 40 it is 1.5. So for your 32 it will be 1, okay, and for 34 it will be 1.1. Understood? So I think it should be 1.2, right? This is 1.1, this is 1.2. I apologize for the mistake. Now let's go ahead. So angle of wall friction. even though IS code here, in IS code you will see that it is suggesting the angle of wall friction may be taken equal to the angle of friction angle of the soil around the pile stem. So IS code is suggesting you can take delta is equal to your phi values. But to be on conservative side, and assuming that because of boring the soil will get disturbed around the pile and it will give lesser skin friction than the original soil, we have assumed a value of delta less phi is equal to 5 minus 3. See, this 32 minus 3, here we have 31, which is actually 34 minus 3. Okay, so this is the angle of wall friction. Now we have shaft area in soil, AS. So what is this area? This is nothing but you need the thickness of the stratum for which you are evaluating the skin friction, and simply it's a, what is the shaft area of a cylindrical shape. So the shaft area AS is equal to shaft area is equal to nothing but pi into D into L, right? So pi we already know, D is the diameter of the pile and L is the thickness of the stratum. So let's see what is there in the formula. So here we have pi into this D11. So what is D11? This is pile diameter, right? 600. We have assumed a pile of 600 mm diameter. So by 1000, because we want to convert it into a meter, and then into C5. What is there in C5? C5 is the depth, total depth, thickness of the stratum. So this is the thickness of the stratum. Actually, I'll modify this title of this column as this is thickness of stratum. Okay, that looks better. Now we have similarly we have obtained this area, shaft area for all the stratifications, all the layers. For all these 4 layers, we have certain length of what we can say the thickness of the stratum in the given soil. So we have evaluated the shaft area which is there in the soil for the given length. Now this is we have already seen. Now we'll see the critical depth. What is critical depth? DC. So critical depth also similar to K value. For critical depth also IS code has seen, this we have already discussed, is note number 5. The for phi is equal to 30, critical depth is 15 times D, and for phi is equal to 40, DC is 20 times D. And beyond 40 degrees, even if your depth is going more than 20D, we'll have to take 20D only for earth pressure calculation. Okay, not earth pressure, actually you can see PD calculation. So PD will be gamma into H, where H is equal to nothing but DC. So it will be gamma into 15D gamma into 20D. This is how we will obtain PD. So we will see here critical depth is 16, for phi is equal to 32. So we will just see for 30 degree we have 15D, for 32 we will have 16D, right? So we have taken 16 here. This is just a, actually this is DC by, you can say D pi. So ratio, we will multiply this value by D to get the depth. Okay, this is just a factor, 16 times diameter of the pile, 17 times diameter of the pile. This is not in meters, this is actually meter by meter, or you can say unit less quantity, right? This is 17 times diameter of the pile. It's like this. 34 means if you interpolate, 34 will give you 17 times D. So for calculation of PD, we will have DC into DP. Actually, this nomenclature I will just say D C. So this is what 16 gamma into gamma dash, actually effective soil unit weight, gamma dash into this factor 16 into the diameter of the pile, where is 600, okay, by 1000 means you are converting it to meters, so this is what you get, gamma into dc, okay. And then we have similarly we have evaluated this one for PD for the fifth stratum, and now we will obtain the skin friction component. So if for these two values, stratum 2 and 3, we have to obtain it from the clay part, and this for this stratum 4 and 5 we'll have to obtain from the expressions for the sandy soils. So let's see what is there in this. So we have, I'll just zoom out. See, so what is there in this clay? It is alpha CAS, right? So where is alpha? Alpha is here 1. Where is C? This is 12. Okay, 1 into C into AS. Okay, this is what you must have understood. Alpha C into AS. Here shaft friction is also alpha C into AS. So we get skin friction for the clay soils in stratum 3. Now we have sandy soils in stratum 4 and 5. So we'll have to use expression for the sandy soils. For sandy soils we have this expression, right? This one, K PDI 10 delta I ASI. So let's see. We have K. First of all, we have to use C. Where is K? So 1.1. K has been utilized. PDI we have evaluated here. 10 of delta. Where is delta? There is delta. So this delta is F7. Okay. So delta we have actually, as per the IS code I have given is equal to 5, but for this calculation let's use delta actually, not the 5 value. So we will see this value is come to you must be knowing already that in Excel, if you want to use a sine or cosine of some angle, you will have to multiply by pi by 180, otherwise it will give wrong results. So just for example I will give you so sine 30, you must be knowing sine 30 is equal to 0.5, right? So let's see what this sine of this 30 gives. This gives a wrong value. This is assuming 30 to be in radians, then only it is giving this 30 value. So for our case this is not in radians, we have to convert it into radians, so we will do sine 30 into pi by 180. Then only it will give the correct value of 0.5. So you must be careful about this while using this formula. These angles have to be in radians. So I have converted into the radians in the expression itself. So we have 10 into M7 is this angle into pi by 180 into ASI. So ASI is this n column to n7. So this is how we have evaluated. Now similarly I'll copy this formula here. So we have this 31 here. So 10 delta 180, everything is same. So this skin friction component you have to sum up. So when we are adding it, it is coming as this thing. Okay. How much? 1745, right? So for end bearing calculations in granular soils, we will be using this first term of Annexure B, B1, which is QU is equal to AP. AP is see, let's see. 0.5, where is AP? This is D17 is AP, area of the pile, which is 0.2728 somewhere, 0.272827 meter square. Then we have 0.5 into D is the diameter of the pile, so we have 600, so D11 by 1000, and one more term, that is gamma, which is E8 is gamma, and then we have J8 is N gamma, which is this term. Okay. Then plus PD into NQ. So PD we have already seen, PD is 96.9, which is already included, and NQ is this one, which is I8. So I8 is the last term. So this gives you end bearing resistance. So we have total resistance will be 1745 plus 679, right? So we'll add both of them together and we'll apply a factor of safety of 2.5. Since we have some part in end bearing, so we'll use a factor of safety of 2.5 as per the IS code. So after giving a factor of safety of 2.5, we get 970.04 kilonewton as the total capacity of the pile in the given soil. So this is how we obtain the pile capacity. So one more thing you must keep in mind, that after 25 meters we have to embed the pile into the soil to up to 4 meters to 4 times diameter to the 5 times diameter. So that means is, suppose your pile is ending in stratum 5. So this is the end of your pile. This is 25 meters. After this, your pile have to go inside the stratum 5 up to 4 times the diameter of the pile, or 5 times the diameter of the pile, depending on the stratum 5 properties. If it is a stronger stratum, you can go little less. If it is a weaker, you have to go a little higher. This is all about the pile vertical load capacity calculations. Thank you for staying till the end, and we'll be uploading next time the pile lateral load carrying capacity as per the Annexure C of the code. Thank you.